solve for x. Here I have 8 raised to the 8 to the x minus 2, and then that's equal to 24. Now the first thing that I'm going to do is I'm going to isolate this exponential. So here I'm going to get rid of the negative 2 by adding 2 to both sides. Now on the left hand side, I'm going to be left with 8 raised to the 8x, and 24 plus 2, that gives me 826. Now that I have my exponential isolated, I'm going to begin to take the logarithm of both sides. So I'm going to get log base 10 of 8 raised to the 8x. I'm going to set that equal to the logarithm of base 10 of 26. So again, I took the logarithm of both sides. That allows me to rewrite my argument, or rewrite this whole expression, because my argument has an exponent. So I'm going to move that. Exponent next to the logarithm, giving me 8x log 8 equal to log of 26. And now I can isolate x by dividing both sides by 8 log 8. And my exact solution would be log of 26 over 8 log 8. Putting this into a calculator, I get an approximation of about 0.12. I'll go over one more example. Here I have 10 multiplied with 16 raised to a negative 3x, and then that's going to equal 38. So the first thing that I'm going to do here is I'm going to divide both sides by 10, just to get rid of that 10 in front of my exponential expression. So dividing by 10 on both sides, on the left hand side, the 10s are going to cancel out, leaving me with 16 to the negative 3x. And then on the right hand side, I'm going to be left with 3.8. Now, because I have a negative exponent, I can further unfold this by applying the negative exponent rule. So I really have 16 over positive 3x. And then that's going to equal 3.8. And I can divide the 3.8 by 1, which allows me to cross multiply. So I get 3.8. I get 3.8 multiplied with 16 to 3x. And then 1 times 1 is just going to give me 1. And now I'm going to divide both sides by 3.8, since I got another scalar in front of my exponential expression. The 3.8s are going to cancel out, leaving me with 16 raised to the 3x equal to 1 over 3.8. Now it's at this point that I'm going to take the logarithm of both sides. So I'm going to get log of 16 to the 3x, and that's going to equal the log of 1 over 3.8. Now that I have a logarithm, I can use a property of logarithms that whenever I have an argument with an exponent, I can move that exponent next to a logarithm. So I get 3x log 16 equal to log of 1 over 3.8. And now to isolate x, I'm going to divide by everything else. So I'm going to divide by 3 and log 16. So on the left hand side, my 3's cancel out, my logs cancel out, so I'm left with x equal to log of 1 over 3.8 divided by 3 log 16. And that would be the exact solution. Putting this into a calculator, I get an approximation of about negative 0.16.